Hello everyone. Today we are working on arithmetic series. So we have learned about sequences so far, but today we are going to focus on our series formula. So a series is a sum of a sequence when finding the sum of an arithmetic series. Use the following formula. It is S of n is equals to n a1 plus an over 2. And where a1 is our first term and n is the number of terms, and a of n usually is our last term in this situation. Now, this formula is given to us in our reference sheet, so you don't have to memorize it, but it's always good to know things by heart as well. For our first example, we always start by, I know I have said that it is arithmetic, but it's always good to check out the pattern, especially to prepare ourselves for the next lesson that we're going to learn about. So let's see, if we have 2 to 4, in order to go there, we add 2. And then we add 2, and then for this one we add 2 again. So the consistent pattern of adding 2 tells us, yes, this is arithmetic. And they also told us that it is arithmetic. So using the arithmetic series formula, we're going to find S of 10. So S of 10 is equals to, wherever I see n, I'm going to substitute a 10. We need a1 plus a 10 over 2. Now, we know what is a1. a1 is given to us, so we can go ahead replace the a1 with a 2 because it is a given information. And I'm going to go ahead put a 2 there. Now, for our next part, which is a of 10, that is not given to us. We do have to find that. So to find that, we have to create our arithmetic formula, which is a of n is equals to a1 plus d n minus 1. Once again, this formula is also given to us in our reference sheet in the regions that we are going to take in the future. So a of n is equals to our a1, which is 2. For our pattern, the difference is 2 and n minus 1. To find our a of 10, I will substitute 10 wherever I see a n, which equals to a 20, meaning wherever I see a of 10, I will replace this with a 20. And after we put this whole thing into the calculator, we should have 10 times 11, and that is going to be equal to 110. So we have 10 times 11, which is equals to 110. And that is our final answer. Now, this sum that we are doing also connects to our sigma notation or summation that we talked about in the previous lesson. So we can also use sigma for ourselves. So for us, if I were to use sigma, I know that our pattern starts at our very first, so n is equal to 1, and we end it at 10 because we are looking for S of 10. And the formula that we are going to put in the middle is the formula that we found with the arithmetic sequence, which is 2 plus 2 and minus 1. And that's how you could also do it as well. So there are two different ways we can find our arithmetic series. Now, there are times we have word formula that kind of throw things off for us a little bit. So let's take a look. Let's read it. We have Karen's New Year's resolution is to work out each day on her elliptical. The number of calories she has burned each day since she started is shown below. Write a rule for the sequence and find the number of calories that Karen will burn on the 30th day. Now, this question right here, we need to first ask ourselves, is this a series or a sequence? Now, sequence mean like we need the 30th term, And series would mean that it's the total of all the term first to 30th term. So this one right here, they didn't say total of, they also didn't say overall. So that means this question right here is a sequence situation and not a series. So we have to be very mindful when we are reading the word problems. And for this one, if we did wanted to find the correct answer for it, I'm going to go ahead and write it down for us. It would be A of n is equals to 349 because that's our A1 value plus 8n minus 1. And then A of 30 would be equals to 349 plus 8 times 30 minus 1, which is equal to a 581. And that's a sequence, not a series. So be mindful when you are reading these problems. And make sure you jot down all the notes. And if you have any questions, bring it to class.